This is a pretty tricky redox titration question from June 2017, paper 1. Okay, so it's about ethane dioate ions, right? Right, and they've got a mixture of sodium ethane dioate, the salt, and the acid, okay, which exists as a hydrated solid. Right, so they've got a volumetric flask, got a solution containing the two, and they did 2 titrations. Now the first titration, save you reading it, or you can pause it if you like and read it. See, the first titration they did was was against potassium manganate. So the first titration, okay, that will potassium manganate will oxidize the ethane dioate ions. Now it doesn't matter if they are present from the sodium salt or from the acid, it will oxidize them both. So that will react with the total ethane dioate content. So just the sodium and the acid. Right, the second titration here, that's against sodium hydroxide, and that obviously won't react with the salt because that's already been neutralized. It only reacts with the acid. So the second titration only the acid itself. So what you've got to do is you've got to find out percentage mass of how much of this solid was sodium ethane dioate. So how are we going to find out that? The sodium, the moles of sodium ethane dioate is going to be equal to the moles in the first titration minus the moles in the second titration, because the second titration only picks up the acid, it doesn't pick up the salt, whereas this first one, yeah, it picks up both of them. So that's the principle of it. That's what we're going to do. Right, so I'm just going to tidy that up and we'll start doing the calculations. Okay, so right, so let's do the first titration then, and I'll stick with the red color for. Well, first of all, we've got a volumetric. Do that in black. A volumetric flask. We've got 250 in there, and you're going to take out 25 centimeters cubed, a tenth of that, for the first titration. And then you're going to take 25 out for the second titration. The second titration is the acid only. And the first titration is the sodium salt and the acid. And the acid, yeah. Okay, so first titration then. We can find out the moles of manganate. That's going to be equal to the concentration times by the volume. Well, let's see, we have got the concentration is 0.02 and of the volume is 26.5 centimeters cubed. So that's going to be equal to 0.02 multiplied by 0.0265 0.50, that's in dm cubed, and that's equal to let me have a look, 5.3 times 10 to the minus 4 moles of manganate. Now look at the ratio in the equation. It's a 2:5 ratio. So to find out the moles of ethylene dioate, we've got to times this, the moles of manganate, by 2.5. So moles of the ethylene dioate, (5.3) times 10 to the minus 4 times 2.5, that's equal to 1.325 times 10 to the minus 3. Now that's the moles in 25 centimeters cubed, but it came from a 250 volumetric flask. So times it by so we're going to do it in 250. The moles is going to be 0.01325. Okay, so that's from the first titration. So I'm going to put that, I'm going to write that up here, the top, because we're going to need it later on. So we put moles C2O4, so that's the acid and the sodium salt, is equal to 0.01325. Okay, that's the total moles of ethylene dioate ions we've got. Right, let's do the second titration now. Which I'll do in blue. Okay, so the second titration, we're titrating against sodium hydroxide, an acid-base titration. So we've got the concentration of the sodium hydroxide is that, and the volume is 10.45 centimeters cubed, quite a small volume. Okay, so moles NaOH, conc times volume, it's going to be 0.1 multiplied by, convert that into dm cubed, 10.45 centimeters cubed is 0.01045 dm cubed. So that's going to be equal to 1.045 times 10 to the minus 3 moles of NaOH. Now, how 2 moles of OH minus react with 1 mole of acid. So the moles of acid then, the moles of H2C2O4 is that times by a half. That's going to be equal to 5.225 times 10 to the minus 4. And don't forget, that's in 25 centimeters cubed. But we had a volumetric flask of 250, so we've got to times that by 10. So in 250, it's going to be 5.225 times 10 to the minus 3 moles. Okay, now, so let's write that up here. So moles H2C2O5, C2O4, that is equal to 5.225 times 10 to the minus 3. Right, so we can move on to the next stage now. So what we've got to do is, we can find out the moles of the sodium salt, Na2C2O4. That's going to be equal to the total mole, so that's the red one here, the moles of the C2O42 minus ions minus the acid, which is the blue one here. Moles of Na2 C2O4. Sorry, the acid, not the salt. H2. So let's do that then. So that is equal to this number, 0.01325 minus the moles of the acid, so 5.225 times 10 to the minus 3. That, you do that, that is equal to 8.025 times 10 to the minus 3. Okay, so we know the moles of that. Now we need to work out the percentage mass of sodium ethane dioate. So we need to work out the actual mass of that. So the mass is going to be equal to the moles times the MR. The MR of ethane dioate, sodium ethane dioate, is going to be 2 times 23 for the sodium, 2 times 12 for the carbon, 4 times 16 for the oxygen, and that comes to be, what is it? 134. So let's do that then. The mass is going to be equal to 8.025 times 10 to the minus 3 multiplied by 134, and that is equal to 1.075 grams. Now it says we need to calculate the percentage of the total white solid. Now the mass of the white solid was 1.9 grams. So the percentage of sodium ethane dioate is going to be equal to 1.075, that's how much that weighs, divided by the total times 1.9 multiplied by 100, and that comes to 56.6%. It says give your answer to the correct number of sig figs. Okay, if you look at every piece of every bit of data there, 3 significant figures, 3, that's the 3, that's the 4, we give it to the, and that's the 3, and so on. So we give it to 3 significant figures is the correct one, the least accurate bit of data. That was about the hardest question titration they've asked ever, I think. About 2017, it was 8 marks going for that. So a pretty massive question. Okay.